This is the RT Grade 12 Practical Exam, Paper 1 from November 2021. And we're going to be going through all the questions, and this is the first video, so we're going to be dealing with just question 1 in this video. So here's the first question, and I've got the files already opened up in Delphi, so I've got them over here. So we'll look at the first bit. So we've got this file, there we go, and we're going down to 1.1. And this is for the form create event, and we are doing a couple of things to the label. We must change the format of LBL Q11. So let's go to the place. So first thing, we want to change the text of the label to the word coding is, okay, and then we want to change the color to green. We want to change the size of the font to 16, and the font must be changed to Arial. So let's go, first of all, let's get to the form create. So let's go to the program. Now to get to the form create, I can just find a part of the form like there, and I'm not going to click on the panel, I'm going to double click on the form there and just double click there, and there we go. The other way to get to that place is if you make sure that the form is selected, you can come here to events and then come here to on create and double click there, and you'll get to the form create. So first thing they wanted me to, we all were changing the LBL Q1_1, I think it was, and that must always, that's the one we always change it. So there we go, that label there, and we're going to change its caption first of all to the word coding is. So dot caption must change to coding is. I think it's just like that, eh? That's it. And then the next thing they wanted me to do, if we look here, they said we wanted to change the color of the text to green. Okay, so the color of the text must be green. So LBL Q1_1. What property? I think that's something to do with the font. So let's go to font, because it's not the color of the actual label, but the color of the text. So is there a color? Oh, there's a color property, and that must be green. Now you can't go just green because it doesn't recognize green as a color, but the colors do have a CL in front. So there we go, CL green. Sounds like an actual singer. I think the CeeLo green is the right one. And then the next is the font size must be 16, and the actual font must be Arial. So let's have a look. So we're still going to be dealing with the font over here. So the font dot, let's see if there's a dot size. There's a size, that must be 16. And then the actual font name, I think something to do with the font name. Font dot name. Let's see if there's a font name. Oh, there's the name, and that must be Arial. Now we must make sure we spell it correctly. I'm not too sure if that is the correct spelling of it. And it's a text field, if I remember correctly. If I just type here dot name, font name, there we go. Just leave it like something. It is a text field, so we can do that. So let's go double check we've got the spelling right. There we go. I think it is right. There we go. So let's just test it. I'm going to run it. There we go. And, oh, there, and the form's created. There you can see coding is, it's green. I think it's 16 and it looks like it's Arial. So there we go. I think that is correct. So we can now move on to question 1.2. So 1.2, it's talking about energy sweets recommended for hikers to have during a break. And they've packaged in rolls of 8 sweets per roll. The hikers normally eat 4 sweets during each break. And then we must use the spin edit cues to find out how many breaks the hiker plans on taking. And the program must determine the number of sweet rolls that must be purchased for the hike. So they actually give me a very step-by-step like way of doing this question. It's quite nice. If you just follow all those steps, you'll probably get all the marks. So let's do the first thing. So let's first of all get to the right place. We're going to open up the program, go back to the form, and we are busy over there. So that's this where we get the number of breaks, SPN Q12. So let's double click on the button. So we're at the right place. So the first thing they want me to do is to create a constant. You remember how to make constants? So a constant called sweets per roll, and that must be an 8 sweets per roll with underscore. So there we go. So the constant, you put CONST. Do you see how it goes blue? And then we can put in our sweets underscore per roll, and that must equal to an 8. You just do that, and that is how you do your constant. It's coming back to you. There we go. So there's my constant, all capitals, so it's fantastic. Then we must declare suitable integer values or variables for the number of breaks, the total number of sweets, and the number of rolls. So number of breaks, number of sweets, and number of rolls. So let's go do that. We're going to declare these integer variables. So I'm going to call it rnum rolls, rnum breaks, and rnum sweets. They don't give me exact names I must use, I don't think, but they must all be integers. So I'm declaring them over there. Let's have a look. They don't give me actual names, that's fine. Extract the number of breaks to be taken during the hike from the spin edit. I'm assuming we're going to put that into the variable for the number of breaks. So let's use that one. So let's come back here. We're going to go, okay, our num breaks variable is going to change to whatever is in SPN Q1 underscore 2. What property do we get? We get the value property. And there you see the value property is an integer. So let's just double check. That is an integer. That is an integer. Do we need to convert? No, that's perfect. Okay, so that's all fine. Then the next step is calculate the number of sweets that a hiker will have during the hike. Assume the hiker will consume 4 sweets during each break. Okay, so the number of sweets, I'm assuming we're going to put it into that variable. And it's just going to be the break times by 4. Okay, well, let's do that. So the num sweets is going to be however many breaks you take. So the num breaks, and we're going to multiply that by 4. I think that seems like it is. That's what they want. Yeah, yes. And then calculate the minimum number of rolls that needed to be purchased to supply the hiker with enough sweets for the hike. Now let's go up a bit. They said there are 8 sweets per roll, and we were asked to make this constant, so I assume we have to use that as well. So that's where the 8 comes in. Calculate the minimum number of rolls. So if we know the number of sweets and we know how many sweets are in a roll, then we just take the number of sweets and we divide it by the number of rolls. Sounds simple, correct? And we are obviously going to put that in the number of rolls variable. So let's go back here. So we can say the num rolls is going to be however many sweets we've got. And we're going to divide that. Now you could be tempted to divide it by 8, but we've been asked to make this constant for a reason. So we should probably use it. They would never ask you to do something unless there was a reason. So we're going to divide it by the constant, so it's going to be divided by 8. Now, there's a couple of problems here. First of all, there's a divide sign, and this is an integer. And second of all, it makes sense because you can't buy half a roll of sweets. It's got to be, you've got full packs of rolls. So if we think about this, I can't round it because I don't want it to round it up or down. I don't want it to ever go down. Because let's say you have 4.5 rolls. You're never going to, or 4.3 rolls, you're never going to go down to 4 because then you're going to be missing sweets. You're always going to be rounding up, basically. It will go up the number. So that means we're going to use the seal function. Remember seal for sealing? It means it rounds almost up to the nearest whole number at the top. And now I think that it needs maths, but I think maths has already been added, thankfully. Just a reminder, make sure that you put your examination number at the top when you are doing your exam. But that's going to round the number up. So if it's going to be 4.5, it'll round up to 5. If it's 4.3, it'll still round up to 5. Because we want to make sure that we get all those sweets. We'll have a couple spare, but that's okay. I'd rather have spare if we need to. And then the last little bit is calculate display. Yes, display the number of rolls in the label. So displayed in the label. So let's have a look. So LBL, and this is the Q2 caption. Must change to how do they wanted me to make it look. It's just the number by itself. I think it's just the number by itself. So let's go just put that num rolls in there. But remember, num rolls is an integer. Caption needs a string. So we convert from an int to a string. And then we can test it. Let's go test it. There we go. So we've got number of breaks. So if we test the data, what data did they give me? They gave me 7 breaks. There should be 4 rolls. So let's try that. 7 breaks. There are 4 rolls. That works out correctly. And if we got 8 breaks, we should still need 4 rolls. There we go. And we'll go up to 9 breaks. Then we're going to go up to 5 rolls. Okay, so it looks like it's working. There we go. Let's go on to question 1.3. Okay, 1.3, they've got a figure that's been compiled using half a sphere and a tetrahedron. Sounds like a dinosaur, that tetrahedron. A solid shape with 4 sides. Okay, great. And we must calculate the volume. I'm assuming they're going to give me some formulas here because I've forgotten all my volume formulas. Okay, the formula to calculate the volume of the combined figure is the volume of the tetrahedron plus half the volume of the sphere. And they already tell me that the volume of the tetrahedron is 133. So I don't even need to work that out. That's just a 133. But the volume of the sphere is that formula. So we're going to put that in there and then divide it by half. Okay, so we're just going to use our formulas. What's the input? Use the information provided to calculate the volume if the radius is a 3. So I need the radius. They say it's a 3. I don't think we get it from anywhere. That's the only unknown that I don't have. And then we must show the message in a show message formatted to 1 decimal. That's weird. There's no input. Is there any input here, Mr.? It's just a diagram. Okay, well, then we're just going to use 3 as the radius. So let's go have a look. So we're going to have to work this out. We could break it up. I could maybe have a variable for my radius. I don't know if that's what they want. And then my final answer, I'll do that as a type real. The reason why I'm making real radius, we'll make it an integer, because that's going to be 3. But our answer is going to be a real. Have you picked up why it's going to be a real? Because if you look here, there's lots of divide, and we're using par. Par is, remember, a real as well. So there we go. There's lots to take in. So first of all, I'm going to set radius to 3, so we can use that variable if we need to. But you actually technically don't need to. But we can do that. And then, so the final answer, let's go, the volume of everything. So the final answer is the volume of the tetrahedron, which is already 133. So there we go. So our answer is equal to the 133, and I think it's plus half the volume of the sphere. So plus half, which is 0.5, or you can say 1 divided by multiplied by the volume of this is where we're going to put the volume of the sphere. And the volume of the sphere is 3 over 4 times by pi times by r squared. So 4 over 3, so 4 divided by 3 multiplied by pi. So I can just type in pi, because pi is a recognized constant basically in Delphi, so we can just use pi, plus times it by the radius to the power of 3 multiplied by the radius to the power of 3. How do we do that? Well, we can use the power function, and I'm going to take the radius, which is r rad, or I could just use 3 to the power of 3. So you could do that. You could have also said r rad times r rad times r rad, or something like that. Those aren't if you want, but I think that is correct. Okay, and then is that it? And then we must display it in a message, show message with 1 decimal, saying volume code. Okay, so let's go to show message. Show message. We're going to say the word volume with a colon, and then we're going to display our answer. Okay, but remember that we want to, this is a real, and show messages need string, so we need to convert this from a real or float to string, but we wanted to put it to 1 decimal place, so we can say float to string f, and it's not any, there's nothing after it, so there's no rand sign or anything, so we can go ff fixed, comma 8, comma 1, because they want 1 decimal place in front of it. I think that's it. We just applied the formula, and they give me an example here of 189.5. Do we get that same answer, Mr. Long? Let's make this, move it up there. Hey, we get the same answer. Yay, yeah, that's great. So we got that one done. Let's move on to 1.4. Okay, so 1.4, we want to get a pattern. We want to draw a pattern with a symbol selected from a combo box. The pattern is a square which consists of the same number of rows and columns, and the number of rows and columns is obtained from the position of the symbol. Okay, so those are the symbols that we got. So for example, I think they must give us some examples. Okay, so there we go. So okay, so there's, we pick the first option, that's only 1, so it's a 1 by 1 grid, which is just itself. But if we pick the dollar sign, you'll see the dollar sign is at position 1, 2, 3. So we want a 3 by 3 grid. Okay, so that's what we need to do. So they give me some little tips here on what to do. We clear the rich edits and so on. So let's try to do this. Okay, so what I'm going to do with my first tip here, whenever we're doing things like this, I'm not worried about the grid. I just want to get that first line right. Okay, so that's going to be my goal. Just get that right. And let's not work on the first one. Let's hope that our formula just works for the first one. It should work. But I'm going to work, let's pretend that dollar sign. Let's focus on that. So we're going to come here. So there's the symbol from the combo box. So the user will select it. So we're going to double click on here. And we are first of all going to clear the rich edit. They said we must do that. Rich edit 14.clear. And what other tips do they give us? Then they say extract the symbol from the combo box. Okay, so we're going to do that. We're going to make a variable. You can make it a character. You can make it a string. I'm going to make it s selected. And that's going to be our top string. And we're going to say s selected. Or select is going to be whatever's in the combo box. Which combo box? Is it combo box? Is it CMB? Mr. Long, not CMB. So CMB combo box, and we're going to get the text property to go find which one is selected. Okay, so now let's pretend that is a $sign. So let's pretend that's the $sign. So we want to create 3 of those. Now, how do we know that it's 3? Well, we know that it's going to be 3 because of its position. Now, if you remember, so that's 1, 2, 3. But remember, to find its position, we need the item index. But the item index of that one is 0, and that's 1, and that's 2. But I wanted to do 3 and 1 and 2. So what I'm basically taking the item index and plussing 1 to it. Does that make sense? So that's 0, but we want to do that 1 time. That's a 1, but we want to do that 2 times. That's a 2, but we want to do it 3 times. So we are going to take that item index. I'm going to make it a max variable. That's the max amount that we must do something. I'll make it an integer. And that max is going to be, our max is going to be whatever the combo box's item index is. Item index, and we're going to add 1 to it. So in this case, item index was 2, but now it's going to be a 3. So now that we've got that, okay. So now I'm going to construct a line of dollars. I'm going to build $3 next to each other. So I'm going to make an S line, and we're going to have some sort of for loop variable. So I'll use R. Okay, so this is how I do it. So I go for loop. R is going to start at 1. How many dollars are we going to build onto each other? We're going to build our max. Okay, so there we go. And we're going to build onto each other. So I'm going to actually go here and initialize S line to nothing. And for this 1, 2, 3, I'm just going to say S line is equal to S line plus the selected character. So S line's nothing. So while it's a 1, add $1. While it's a 2, add $1. While it's a 3, add $1. And there we go. You can even put this in begins and ends if you want, just to be sure. Okay, but there we go. So that's how we know that it's an end of the R loop. Okay, and let's just display it. We're going to display that in the memo control. So the rich edit, I think it's arq4.lines.add. We're going to add S line. Let's just test that to see that it works. It's not doing the grid, it's just doing 1 line at a time. So let's just see if we can get that working. And then we can modify that to be a grid. So if I select that one and display pattern, it displays 2. That's great. If I display the $, it displays 3. That's great. Now let's go back up. Let's see if it works for the 1. It should work because it goes from 1 to 1. So yeah, it makes sense. And then that one, there we go. So it's definitely doing that. Okay, so we got the 1 line done. So we got 1 line done, but now I need to repeat that process 3 times. Why 3 times? Because that's how many times I went across. The same number of times that I went across is the same number of times I must go down. So basically I'm going to do all of this. I want to do this now 3 times as well. So I'm going to put all of this inside its own. So let's mark it off so you can see. So all of this must be in its own for loop. So we're going to have another for loop. Let's call it J. And that's also going to do it 1 to our max. And what are we doing each time? Well, begin. And we're going to put an end over here. This is the end of the J loop. Okay, and then all of this now fits inside of that. So now I can move this up a bit just to indent it a little bit. But there we go. So the reason why I also initialize, because just a little tip here, that initialization must happen inside the loop, because once I've created those $3 and I've added it and I go back here, now we're going to do the new loop. I want to reset that back to nothing, because if I don't, it's going to have $3 in already. It's going to add a 4th and a 5th and a 6th. And we must just make sure we declare our J variable. So by just working out the first line and getting it working, we can then go put another loop around that to make it do all the rest. I hope. Let's see if it works. And Eureka, there we go. It's working. I think it's working. There we go. Let's try for 1. Should just do a 1 by 1 grid. There we go. No special cases at all. It's perfect. There we go. So that's 1.4. So when you've got grids and stuff like that, like especially when you're using multiple loops, nested loops, I first focus on the first row, get it working, get it perfect, and then you can do the outer loop around that code. And now our final question for this paper is 1.5, or for this question part, is a string must be compiled by randomly generating uppercase letters of the alphabet until the same letter is generated consecutively. In other words, we've got two B's next to each other or two Z's or whatever. So they give you some ideas. Randomly generate a capital letter from the range A to Z. Compile a string using the generated letters. Repeat this process until the generated letter is a duplicate of the previous last letter that was generated. Okay, display the generated string. So if you see there, all random digits, but the last two, those two are the same when they're like that. So because it's random, we're not going to get those results. They could be different every time, but as long as the last two characters are the same, that's what we must do. Okay, so they talk about the ASCII values. I'm going to do it without the ASCII values, and I'll show you what to modify to get it to use the ASCII values. But I think they want to use the CHR function to try to get the character based on a number, but I think we can do it without that part. So let's go have a look. So we're going to go to the code. So here we go. We're on this little part here, and they've cleared it, and they've variable to build the output string. So there's S out. So we must just go from here. Okay, well, what I'm going to do here is I'm going to do a string called S alpha, which is going to be all my possible letters that I want to use. S alpha. So I'm going to say S alpha. Did I spell it right? S alpha is going to be all the possible letters like A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R. Are you also singing like I am? S, T, U, V, W, X, Y, Z. Did you also sing that? We all sing the alphabet whenever we say repeat the alphabet. So there's my alphabet string. Okay. So we know that that's 1 and that should be 26. So we want to generate a random number. So I'm going to go generate a random number. Rand of type integer. And rand. So we're going to keep on generating random numbers. So we got S out that's equal to nothing. And we're going to repeatedly do something until something happens. We're going to repeatedly generate a random number. Rand is equal to a random range number starting from 1 until how many letters in the alphabet? 27, no, 26. But remember, with random range, you always go 1 above our upper limits. So we want 26, so we just go 1 above it. So that's going to generate a random number, and we want to get our letter. So I'm going to get my S letter, which is going to be S letter is we're going to copy from S alpha. So copy from here, starting at the position of the random number. So if we generate a random number of 3, that's going to go and get that letter, and we want to copy 1 character. So it's going to copy 1 character from this lovely little string every single time. So there we go. And we're going to take that string and we're going to say S out. Sout is equal to sout plus this letter. Okay, does that make sense? Okay, and we want to keep doing this until S letter equals to the previous letter. Okay, so how do we get the previous letter? Well, it takes a bit of mathematics here, so let's just double check. So at the moment, let's pretend this is my string. I'm going to put it over here. So let's go put some random stuff there, and then we've got BB. So this is the letter that I've just added on, okay? And the length of the string is 1, 2, 3, 4, 5, 6, 7. So it's a length of 7. Okay, so it's a length of 7. So we want to compare the 6th letter with the letter that we just got. If it repeat until that letter is the same as the length minus 1. Okay, so we're going to copy, okay, from S, not from S out, starting at the length minus 1. Did you understand that? So we want to copy from the length minus 1. We want to start there, copy 1 character to go get that particular one. So the length of S out minus 1. So that'll get me this. And if I copy just for 1 character,
So this over here is copying the second last character. So if there's 7, go to the 6th position, copy one character. If that is the same as the letter we just generated and added on, which is the last letter, then we can stop doing this, and then we can display. I think we just, in the rich edit, we add it. Rich edit 1.4.lines.add, not create, Mr. Long, lines.add s out. We just add it. Sout. Do they have any little headings in front of it? No. So let's test it to see what it does. But does that make sense? So we made this alpha string. We randomly generate numbers, a number from the alphabet, and we go fetch that particular number from the alphabet. So we copy from the alphabet that random number, so that particular one for one character, and we add that onto our string every single time. That's why it's initialized. And we keep doing that until the second last letter is equal to the letter we just added. So let's test it and hope for the best. As I said, our results will not be the same as the examples, but as long as we see the last two characters the same. Okay, that's weird. So what is it doing it wrong, Mr. Long? Is it possible that because the first time we do this, our string it can't really compare the previous position with it? I wonder if that's... Let's try put in a default value into sout before we start. So let's say sout is equal, and let's do this part right to the beginning almost. We're going to generate a random number, and then we are going to do this whole thing. We're going to say sout is equal to sout. We'll give it a starting value. I'm going to copy a random number. So I'm just giving a starting number before. So it's at least got one letter before we start doing this. So that at least when it's comparing with the second last, at least there are two characters. Let's test to see if that works. If not, we'll make some more changes. So let's run it. It's over the best. Boom. There we go. I think that fixes it. So that's the problem. We needed it to have... See, when we did that, it only had one character. So I was struggling to find the second last character, because it doesn't have two characters to compare. The first time I did it, there was only one character. But now, it's got a starting character, so we generate a random one, so it's already got two by the time we do the checking. So we just give it a default value. So let's try it again. There we go. All random, and the last two are the same. There we go. I think that works well. Okay, if I wanted to use the other option, instead of using this combination there, you could have said the letter is equal to the char function, which takes in a number. I think it takes in a number of the ASCII value. Now we want an ASCII value, and we want a random range. We want all ASCII values, and they told us from 65 until 90. So, well, 91. Remember, it's always got one above. So from 65, 91. So go generate a random number, and then go get that ASCII value. And it looks a little bit more simpler. But if you didn't know the char function, then you couldn't do it. So let's test if that works. I think that's going to work. And it'll pretty much do the exact same thing. There we go. It does the exact same thing. So you can do that as well. But yeah, if you didn't know about the char function, then you can use this idea. I like that one, but that's just me. Okay, there we go. That's question 1. Let's move on to question 2 in our next video. Links to the other questions can be found in the video description. Support the channel by clicking on that subscribe button, leave a like, leave a comment, go to the playlist to find other exam papers to help you. And remember, don't do it the long way, do it the Mr. Long way.